there? Hello? Hello, are you there? Hello? We have lost signal. This is quite unfortunate. If you are there, say yes, please. Hello? Are you there? Please, if you are there, say yes. Tap yes. Tap yes. Tap yes if you are there. Hello? Was the signal lost? Was the signal lost? Was the signal lost? That's quite unfortunate. Was the signal lost? Hey, sorry. Sorry about that. Sorry about that. Sorry about that. Sorry about that. Thanks for your patience. Thanks for your patience. Thanks for your patience. Oh, sorry about the signal that is lost. Okay. So let's continue. Well, the video is being processed. So if you lost the signal and you didn't hear what I said when the signal was lost, don't worry, you can rewatch the video. I can assure you, you can rewatch the video. Sorry about the signal that was lost. Now, this is the fourth question we are going to solve in partial fraction. And like I was saying, when the signal was lost, I said this particular question has its application in relation to what? Rule 4. Rule 4 could be used to solve this question. Now, like I told you when we started, you have to be very careful before you start answering question in partial fraction. If you don't take care, if you are not cautious enough to examine the nature of the denominator, you will run into trouble. Yes. Now, look at this denominator. We have two types of denominator here. We have two types of denominator here. We have a linear denominator and we have a linear that is repeated. Yes. A linear repeated denominator. A linear repeated denominator. So for that reason alone, you have to be careful. You have to be careful. So now let's resolve. Let's resolve. The first linear, let's write it out. 7x plus 2 all over 2x minus 3 into x plus 1 all squared can be what? For linear, a all over 2x minus 3 plus, now that you have one linear repeated, you know, the repeatedness there means that you will reintroduce two constants. Yes, because it is repeated twice. So that's that. B all over x plus 1, yes. Now plus c all over x plus 1 squared. That is the meaning. That is the meaning. That is the meaning. That is the meaning. Are we together? Are we together? Let me hear from you, please. Let me hear from you. Oh, okay. Are we together? Are we together, please? Okay, thank you very much. Thank you very much. God bless you. Now, let me re-explain again. We have two pairs of denominators here. This one is linear. The second one is equally linear, but it's not ordinary linear. It is repeated because you have square there. It's like x plus 1 times x plus 1. But it is not that we are going to split it that way. Our splitting means you pick the first linear without this square. You give it a constant. Now, for the second linear with a repeated quotient, you now give another constant to it. Suppose we have 3 here. After we have used a over 2x plus 2x minus 3, the constant for the linear here, you pick b over x plus 1 plus c over x plus 1 squared plus d over x plus 1 raised power 3. Yes, it has to be in three places. Okay, good. So let's find the LCM. Our LCM is 2x minus 3. You know, x plus 1 can be found in x plus 1 squared. So you can just pick x plus 1 squared because this one is more than this. This is in this. So we don't need to write everything. This one can be found in this. So that's why I pick the one that is square. Now, so 2x minus 3 and 2x minus, it will remain this. So you have what? A into bracket x plus 1 squared plus x plus 1 cancelling. You know, x plus 1 square means x plus 1 in two places. So if you use to cancel one, if we use x plus 1 here to cancel 1 out of it, it will still remain x plus 1. So that's b into x plus 1, then multiply by 2x minus 3. That's beautiful. Now plus, now x plus 1 squared cancelling x plus 1 squared. You have this left. So c into 2x minus 3. Do you understand that? Do you understand that? Okay. Okay. So let's write, let's equate the numerator. Let's equate the numerator. So we equate the numerator. Don't forget, this is like 7x plus 2 all over 2x minus 3x plus 1 all squared. So equating the numerator, we have 7x plus 2 equal to or correspond to a into x plus 1 all squared plus b into x plus 1 2x minus 3 plus c into 2x minus 3. Yes. Okay. Now, let's now look at how we can eliminate A, B, and C. Now, we can apply, we can use cover-up method, but its application is limited here. Yes. So it would be better we use the general expansion method. Although B will be eliminated here, C will be eliminated here, but you still remain this. So let's just use direct method directly so as not to have issues. Okay. Now expansion. 7x plus 2 into a into, when you expand x plus 1, you have x squared plus 2x plus 1. That's the expansion of this. Okay. Plus b into x times 2x, 2x squared, x times minus 3, minus 3x, plus 1 times 2x plus 2x, plus 1 times minus 3 minus 3, then plus expanding is 2xc minus 3c. So we have 7x plus 2 is equal to a into, this could be equal to or correspond to. Now, no, we are expanding now, ax squared plus 2ax, that is we are multiplying out by a, plus 1 times a plus a plus, we can okay, let's close this one. Let's close it. Minus 3x plus 2x, that's minus x minus 3 plus 2xc minus 3c. So we have 7x plus 2 ax squared plus 2ax plus a plus 2b x squared, that is when you use b to open the bracket, then minus bx minus 3b plus 2xc minus 3c. Now, I hope that is clear. I hope that is clear. I hope that is clear, please. I hope that is clear. I hope that is clear. I want to hear from you. I hope that expansion is clear. I hope that expansion is clear. Okay, thank you. Thank you. So now we compare, without wasting our time, I've taught you something very close to this before. Let's compare the coefficient of what? X squared. Sorry, compare the coefficient of x squared, x, and constant. We want to compare them. On this left-hand side, there's no x squared, so we write 0. On the right-hand side, we have ax squared plus 2bx squared. Yes. So the divide through by x squared, this one give us, it will still be 0, equals to a plus 2b. So let's call that one equation 1. Because this one does not have a square. So if you divide everything by x squared, this will be a, this will be 2b, this is 0. Now let's compare x. We have 7x, those that have x. 2ax minus bx plus 2xc. Those are the ones that have what? They have x. Oh yeah. Divide through by x. 7 equal to 2a minus b plus 2c. Let's call this one equation 2. I think we will need to write them somewhere so that 0 equals to a plus 2b. Let me write somewhere so that I will not have issues when I need them. 2a minus b plus 2c. Equation 2, equation 1. I think I shouldn't have issues when I need them. Okay, now I want to clean them. I want to clean my no, before I clean, let me find the constant. Let me find the constant. Before I clean everything, let me find the constant. Let me compare the constants. Now this is the equation I'm considering. So the constant is plus 2. That's 2 is equal to a. Are we together? Oh, let me write this. 2 is equals to a. Minus 3c. No, minus 3b a minus 3b minus 3c. So these are constant. We can call this one equation 3. I think I'm right. Let me check well so that we don't have issues. So now what happens? Let's check. We are now going to combine the 3 equations together so that we'll be able to get the values of a, b, c. Now let me combine them together. We now combine equations 1, 2, and 3 as let's write it as a plus 2b is equals to 0. 2a minus b plus 2c is equals to 7. And a minus 3b minus 3c is equals to 2. Equation 1, equation 2, equation 3. Now, if you look at these equations, they are interesting equations anyway. Let's first of all combine. There are ways of doing it. Okay, in equation 1, there's no c. Yes, there's no c. So you can pick it up here this way. You can say that if we look for a and replace all a with b, so we are almost left with only b in 2 and 3. I think that will work well. That is substituting, putting equation 1 in equation 2 and equation 3 and now combine. I think that will work for us. It's a good method so that we'll have reduced everything to what is what I'm saying. Okay, let's say put equation 1 into 2. We get, let me write it clearly. We get equation 1 is what? Equation 1 is a will equals to minus 2b. If I want to make a the subject of formula, so I transfer 2b here and become minus. Please, are we following? I want to hear from us. Are we following, please? My students, are we following? Let me hear from you. Hope we have not lost signal again. Thank you very much. Thank you. God bless you. You are wonderful children. Shall be well with you in Jesus' name. Amen. Okay. Now I said we want to make a the subject formula here. What we are trying to do is that we want to reduce the constants that we have in equation 2 and 3 to 2. We have 3, a, b, c. So if you reduce them to 2, they will be easy to deal with. So I said, let's suppose we want to make a the subject formula here. A will become what? Because by the time plus 2b comes here, become minus 2b. So let's go. So put, okay, that is equation 1 into 2 now. Therefore, equation 2 now what? 2 into, my a is now what? Minus 2b minus b plus 2c equals 7. Yes. Or let me write it this way. Let me write this way so that you understand it very well. I can say from equation 1, a is equals to minus 2b. Now, now put a is equals to minus 2b into equation 2 and 3. Now I want to put a equals to minus 2b into equation 2 and 3. So when I put a equals to minus 2b here, this one will be minus 2b minus b. Oh yeah. We now have minus 4b minus b plus 2c equals to 7. What is minus 4b minus b? That's minus 5b plus 2c equals to 7. We can call this one equation 4. Hey, I think we have to write this equation somewhere so that we will not have issues. So minus 5b plus 2c is equals to 7. Okay, that's our equation 4. I've written it somewhere. Good. Now let's put, we said, now put a equals to minus 2b into equation 2 and 3. When we put a equals to minus 2b into equation 2, we got equation 4. Now we put a equals to minus 2b into equation 3 now to get equation 5. What is equation 3? A minus 3b minus 3c equals to 2. Oh yeah. Now put a equals to minus 2b. So we have what? Minus 2b, because this is a. A will now change to minus 2b. Minus 3b, minus 3c, is equals to 2. Is equals to 2. Okay. Now this what? Minus 5b, minus 3c equals to 2. Good. Good. That's now equation what? Equation 5. That's now equation 5. That's our equation 5. Good. So we now combine equation 4 and 5. Now we combine equations 4 and 5. Oh yeah, as what is equation 4? Minus 5b plus 2c equals 7. Minus 5b minus 3c equals 2. Equation 4, equation 5. Good. Brilliant. Brilliant. You see that it will be easy for us to get B and C now. Yes. It will be easy for us to get B and C. Oh yeah. Now you observe closely that 5b is common, but still we cannot eliminate them like that because they have the same sign. Before you can eliminate them, one must have a positive sign, while the other one will have a negative sign. So what do we do to get positive sign here? We now subtract. Now say subtract equation 5 from 4. Oh yeah, that is minus 5b plus 2c equals to 7. By the time you introduce minus here, it becomes plus 5b plus 3c equals to minus 2. Because that minus you are subtracting means you multiply everything there by minus. Now this one will cancel this. Minus 5b plus 5b. Now this one will now be 2c plus 3c. That's 5c. 7 minus 2. That's 5. So dividing both sides by what? By 5. C equals to 5 over 5, which is 1. Beautiful. Beautiful. Our C is 1. Now, how do we now get B? Can put B, put C equals to 1 in any equation 4 or 5. Anyone. Can say equation 4 if you like. Oh yeah. Now, minus 5b plus 2 times 1 equals to 7. Good. Minus 5b plus 2 equals to 7. Good. This one will become what? Minus 5b equals to 7 minus 2. Minus 5b equals to 5. Abi? And that's why b equals to 5. Yes. So how do you now get b? That is very easy. That's very easy. Divide both sides by minus 5. So b will be equals to 5 all over minus 5. I think that is clear. B equals to what? Let me write it. B is equals to 5 all over minus 5. And that is minus 1. Because minus times plus is minus. 5 and 5 is 1. So we have gotten B to what? C is what? C is 1. B is minus 1. Now, how do we now get our A? How do we get our A? Okay. We now go back to, we said A is equals to minus 2B or so. Anyway, if you have forgotten that, we will get it. Yes. Since A is equals to minus 2B, therefore, A will now be equals to minus 2 times, what is our B? Minus 1. So A is equals to plus 2. Because minus times minus is plus. A is equals to plus 2. So now, finally, the resolved partial fraction is, let's say finally, let me write down here, A equals to 2. So finally, the resolved partial fraction, the resolved partial fraction, what was our fraction? Oh, can we still remember? Hey, A all over, can we still remember 2x minus 3 plus B all over x plus 1 plus C all over x plus 1 squared. Will now be, our A is 2 all over 2x minus 3 plus B. So plus times B is minus 1. So that will be minus, plus times minus is minus 1 over x plus 1 plus our C is 1 over x plus 1 all squared. So this is the resolved partial fraction. That is the resolved partial fraction. Please, any question there? Any question there? Any question there? Do you have any question there? If you observe closely, you will see that all these things are things you can learn and understand if you take your time to watch the video very well. Watch it thoroughly well. Watch it, learn the way the questions are solved. There is no problem, you will get there. Yes, once you are able to give yourself enough time, to watch the video, you will definitely get how they are solved. I can assure you that. Now, let me give us assignments. These assignments will complement the assignment I've earlier given you. And I want you to submit the assignments latest. Today is Sunday, latest Wednesday. There will be scores for this assignment too. Yes. Because I observed that some of you are not submitting assignments. Yes. It was only very few of you that submitted assignments, the one I gave you last time. And that is not good enough. If you want to be an expert, if you want to acquire mathematics skills, you have to do assignments. You have to do a lot of exercises. But if you refuse to be doing exercises, then it will be difficult for you, to acquire the skills. It will be difficult for you to acquire the skills. So, let me look for some questions for us here. And I want the assignment to be submitted latest on on Wednesday. And it should be submitted to my what? It should be submitted to my Gmail, the one you are familiar with. So these are the assignments. Mind you, these assignments, that it will be graded. I'm going to grade it. Yes. I'm going to grade it. Because the last time I came on board to teach you here, Because I said it's an exercise, some of you did not do it. So I'm going to mark this. I will upgrade it. I'm serious about it. Resolve. I'm serious about it. Latest Wednesday. On my what? On my Gmail. Resolve the following into partial fractions. I'm going to grade it. 1. 4x plus 11 all over x squared plus 4x minus 5. 2. 13 minus 5x squared all over x squared minus 1 x plus 3. That's that. Number 3, 2x cubed plus 2x squared plus 2 all over x plus 1 squared x squared plus 1. I'm trying to give you varieties so that you don't complain that I think so that I'll be able to mark it and return the scores to you. Let's say I said I'm going to grade it and it will serve as your assignment. I mean your attendance. Yes, I'm going to grade it. I'm serious about this. So this assignment should be submitted latest. Even that Wednesday is just to allow you enough time to do it. So I want it latest Wednesday. When I say Wednesday, by AM, by the midnight of Wednesday, I must have seen them in my Gmail. If you have lost Gmail, contact your what? HOCs. Contact your HOCs. Thank you very much. Before we move on, I want to ask, should we still continue or we should meet next time? Probably next Sunday. Should we continue or should we meet next Sunday? Should we continue? Should we continue? Should we continue? Because we want to study polynomials too. Some of your colleagues they said they had issues on polynomials. Should we continue with polynomials? Yes or no? Next Sunday, next time. Okay, next time. Thank you very much for your time. Thank you very much for your time. Thank you very much for your time. God bless you. God bless you. God bless you. Now let me quickly give you this hint before you go. Now, please, I want to beg you. It's always nice, always good like this when an expert, takes you, give you a walkthrough, a set of questions, and most times you always enjoy classes like this. You say, you enjoy it, it was okay. But like I used to tell you, always practice whatever you have been taught. Practice makes perfection. Don't ignore what we have learned today. What you have done today, don't say you have understood it. Lay your hands on each of these questions, attempt them, because you don't know which one will come out in your examination or test. So you need to practice, because it is after your practice that you become a perfect person. Please, always try to lay your hands on this. And I believe strongly that when you practice continuously, consistently, you will acquire the mathematics skills. So, by the grace of God, same time next Sunday, we meet again. God bless you. Have a wonderful weekend. And have a wonderful week ahead of you. Thank you.